let's talk about cloud formation. You have sensible heating versus latent heating are the two types of heating that goes on in the atmosphere. Sensible heating is also called free convection. What's taken place in the atmosphere is you've got the sunlight striking the ground's being heated up by that sunlight, and then the ground will heat the air, just the lowest part of the air that touches the ground. That will cause the air to become less dense because it's warming up, and it will begin to rise. And you can get a rising motion started just by sensible heating. You ever notice in the late afternoon that it was clear during the morning, and then all of a sudden there's all these puffy cumulus clouds that just randomly appear? And then once the sun goes down, they disappear. If you've ever noticed that phenomenon, more so in the summertime, although it can happen any time of the year, but you will notice it a lot more in the summer. What you just witnessed was the free convection, or that sensible heating, taking place. As the sun continued to shine and heat that ground up, it continued to get warmer. That lowest layer of air that touches the ground gets heated, becomes less dense, it starts to rise, and it causes all those rising motions. And then a cloud will form. There's other ways to get clouds to form through latent heating. Latent heating is the deposit or loss of energy because of the phase change of water. So anytime you've got water changing states, going from a gas to a liquid or gas to a solid, then there's energy being released during what's called the adiabatic process. And it's just a thermodynamic process in which no heat is exchanged between the atmosphere and that air parcel. Now when I say air parcel, I'm just talking about a little blob of air that has the same pressure and temperature as its surroundings. Now in that adiabatic process, you have compressional warming and expansional cooling. That expansional cooling is when an air parcel starts at the surface and it begins to rise up. As it gets up into the atmosphere, there's less pressure, and so there's less constrictions on that air parcel, and it allows that air parcel to expand. And when it expands, it begins to cool down. That's how the atmosphere can be cooled. Now if there's any moisture within that air parcel, then you're going to end up cooling it down to where condensation could take place. So as an air parcel rises, it expands, it cools, and then it's going to condense. That's expansional cooling, and that can help form a cloud. Now on the flip side of that, there's what's called compressional warming. Instead of that air parcel rising, that air parcel can also sink to the ground. As that air parcel sinks, the pressure becomes more and more, and now all of a sudden there's a lot more constrictions on that air parcel. It's not expanding anymore, it would be contracting, and that can heat up that air parcel. And if the air is sinking and the air is heating up, you're not going to get a cloud to form. Now you can see this kind of thing in nature if you're near a mountain. You ever heard of those Chinook winds or those Santa Ana winds in California? Those are both hot, dry winds, and they're on the leeward side of a mountain. What that means is the air is descending down the mountain, so it's going down. The air parcels are all contracting and they're heating up. So it's a very dry and a very hot wind. If you've ever been out to or lived in West Kansas, you may have experienced this.
One day in the wintertime, it could be like 30 degrees, and the next day be near 90 because of these hot winds that can come down the side of the mountain.
And those Santa Ana winds in California can help spur wildfires or keep them going because there's such hot and dry winds. Remember, the sensible heating is also the free convection. Well, there's other ways to also get the air to rise, and that's called forced convection. Forced convection could be from a frontal system coming through, a cold front, a warm front, or a dry line. It could be from convergence of winds. Florida gets a lot of those convergence of winds, where they get winds coming off of the Atlantic Ocean and winds coming off the Gulf of Mexico, and they kind of meet in the middle. And there's a lot of thunderstorms that take place. Fronts, of course, come through everywhere. You also have orographic lift, where you have lift taking place on what's called the windward side of the mountain, where the winds come, they strike the mountain. Well, wind can't go in a mountain, and it can't go down into the ground, so it's forced to go up, and you can get a lot of rain on the windward side of a mountain. If you've ever been to Hawaii and explored the entire islands, you know that there's a windward side, a very pretty, lush, tropically side, and there's another side on the leeward side of the mountain, and it's just dry. Compressional warming taking place there. So we've looked at all the pieces on how clouds form, so let's kind of get down to it. You need three things for clouds to form. You need that lift,
Cold front, warm front, orographic lift, convergence, something to force the air to rise, or the free convection.
You gotta have moisture, and you have to have what's called cloud condensation nuclei. called CCN. Cloud condensation nuclei is always present in the atmosphere.
It's your dust, your smoke, your clays, your organic particles, all stuff that's microscopic that you can't see.
It's always present. It's nothing new. It's not like all of a sudden there's these cloud condensation nuclei that just kind of pop in the atmosphere and we're all so dirty. It's always present. Granted, we could have pollution and add a little bit more to it, but there's always going to be those particles present. Volcanoes put them off all the time. Okay, so we got the three things we need: lift, cloud condensation nuclei, and moisture. If the air is rising, then as it goes up, that expansional cooling will take place. It will allow that air parcel to expand. It cools down, which allows the moisture to condense out of that air parcel. If it has something to cling on to, that cloud condensation nuclei, then the cloud's able to form. So lift, it condenses on the cloud condensation nuclei, and boom, you got yourself a cloud. You ever wonder why you see those contrail clouds that go behind a jet engine? Well, they're kind of creating everything they need right there in a small little area. It never lasts very long, because once it goes through, it kind of stops the process taking place. The more lift you have, the bigger the cloud's going to be, meaning vertically. That's how you can get those big cumulonimbus thunderstorm clouds. Continue to have that sunshine, have a front come through, heating the ground with that sunshine. All that stuff can continue to lift and keep the air rising and rising. The more it rises, the larger those clouds can end up becoming. So let's look at how a cloud forms. I got a 2-liter bottle. I have a little bit of moisture in there. You can see some of the water droplets in there. I can heat this thing up by squeezing the bottle.
Note the temperature is 75.1 until compression is added. Watch the temperature change. It ends at 76.7, and then once you release it, the expansional cooling has taken place. The temperature drops.
Squeezing it, I'm going to increase the temperature. And when I let go of it, the temperature is going to drop, and I'm going to cause expansional cooling when I release it. So compressional warming, expansional cooling. Remember that. I can cause that expansional cooling all I want. I got moisture. I'm forcing the lift myself by doing that, so I'm causing the air to cool down in order to condense to make a cloud. But you don't see a cloud, right? Why isn't there a cloud? What am I missing? I'm missing cloud condensation nuclei. If you try this, be careful, because obviously I'm playing with fire. Can you see the smoke? Smoke is cloud condensation nuclei. Let's see if I can get a cloud to form now. And the more you squeeze it, the better the cloud's going to be. Cloudy, clear. Cloudy, clear. Pretty cool, huh? Cloudy, now clear. Cloudy, boom. Now you can see me, now you can't. Now you can see me, now you can't. Pretty nifty, huh? Compressional warming. Let's make it do expansional cooling. Boom. Cloud in a bottle. Science is pretty damn cool. Other than that,